Um, all right, great. Well, thanks everybody for joining this latest installment of Blockheads. It's a really exciting one, not just for the subject matter, but for who's speaking. I see Sue is on here, some other people who have worked closely with Professor Matt Adams before. Just a little bit of background on Matt. So Matt runs a sustainable concrete and cement lab at NJIT. And so his day job is to actually think about all these things, but he has other hats that he wears as well. He was a Rockefeller Policy Fellow in New York, focusing on exploring public policy sort of options that can be done at the state level around decarbonizing these materials. And very pertinent to today, he is the kind of convening author, chair of material recycling at the American Concrete Institute, and was the lead author of this new code that we'll be discussing today. But I'll also say, as I've worked really closely with Matt, I think Matt and I have probably known each other for about 3 years, if not longer, I would say at this point. And he's always been the person who has such high credibility, who I could bring to talk to relevant stakeholders and legislators. Oops, someone can go on mute there. He's always been kind of the expert or the guru that we're able to kind of bring in and speak credibly about the subject to people who make decisions. And so he's an engineer, but with a rare flair for advocacy, I guess I would say. So, Matt, anything I left out there that you'd want to add that's germane?
No, I mean that's a good summary. I run an experimental research lab. I also do research on policy, and I'm pretty involved in the standardization community around concrete. So I've been doing this for about 20 years now. So I've been in low carbon sustainable systems for about 20 years, and it's nice to see in the last 4 or 5 that they're starting to get a lot of attention and use. So it's
Yeah. Matt, are you from New Hampshire?
I am. I grew up in New
Ah,
Hampshire.
there you go. All right. Sorry, I
One
didn't mean
one
to out
thing that
that.
neither of you mentioned, which I think everybody here should know, is that Matt's a fellow at the ACI, at the American Concrete Institute.
Payments are yours.
Yeah.
Well, thank you for catching that.
Well, we'll have you. Oh, let's go unmute it there. We'll have Matt tell us a little bit about what the ACI is in a second. But Matt, to just kind of get you up to speed. So this group here that we call the Blockheads are folks within either open air or Citizens Climate Lobby and probably other people, Foundations for Climate Restoration, that have a particular interest in the decarbonization of concrete, which, includes many things, including utilization of carbon in concrete. And we have a couple of bills that are already either live or will be live shortly that are either a LECLA-like type of thing or some variation of that. So we have one going in Pennsylvania. I had a great call with that team yesterday. The bill in Illinois, which is LECLA for both concrete and it will also include asphalt, and then a much more mammoth bill with a lot of things in Colorado. And I was just on a call with my NRDC colleagues about Colorado, about this code actually, and how do we sort of leverage the new arrival of the code to kind of get things done for our bill in Colorado. So we'll probably be talking quite a bit this session. And one of the things that I mentioned the last couple times we've been on here is this. We already were thinking in the abstract around maximum global warming potential at the municipal level in the code, already looking at what places like Marin have done, what Boulder County is exploring, what New York City is also. I don't know if you know that yet, but they're trying to get that done in New York City.
Mhm.
And then I reached out to you and you're like, oh, by the way, this is coming out like tomorrow. And so it's just great timing for us to know about this and also to potentially try to advocate for it as we get into the new year. So Matt, let's kind of start with you a little bit. First, this is a code which I'll have you describe what does that mean and what does it fit within. But first, tell us like what's the American Concrete Institute and what is the role they have over shaping new building codes as they pertain to concrete?
Yeah, so the American Concrete Institute is it's an industry organization focused on concrete, both in the structural design and material science world. Um, it's unlike some of the other organizations, it's not member driven in terms of companies being members. It's individual members So we've got people from academia, we've got people from industry, we have people from government, sort of all walks of life in there. And they're really sort of the independent rulemaking body for concrete. So the structural building code for using concrete comes out of there. The building code for precast concrete, all of the guides for making concrete durable, things like that come out of there. The one thing that really doesn't come out of the American Concrete Institute is much on concrete pavements because that's sort of run by the government AASHTO body, the American Association of State Highway and Transportation Officials. But so basically everything else that's concrete comes out of ACI. And then there's also just a lot of committees within there that are looking at specific factors of concrete. So everything from, the rocks that go into it to the chemicals we use to the different types of cements to all of these new materials that are coming in. Pretty much there's an expert group at ACI for that. And we all meet pretty regularly to kind of make sure that guides are up to state of the art. All of our codes are developed through the ANSI consensus process, which means that the membership of the code committee has to be balanced. So you can't have too many people from industry, you can't have too many people from academia, et cetera. Goes through a whole process of voting that requires kind of more than just having a vote of the majority. If people vote negative, you have to resolve it. That's basically the whole process that's required for something to actually become a code. And codes are written in what we call mandatory language. So it's not a suggestion, it's a you will do this. And so once a code is adopted by a state, it becomes law. But a code doesn't necessarily have to be adopted by a state to be used, right? You can have different towns adopt it. You can even just have owners say, we want you to follow this code in the design of this structure, or this pavement or whatever. So there's a lot of ways to actually utilize a code before it gets into the sort of main building code system, which we are an industry that moves slow. So that can take some time. Sustainability with concrete is moving faster than anything with concrete ever has. But in general, because of life safety issues, we're generally a slow moving industry. And the code processes take years to a decade to kind of move through one full cycle.
Okay, great. And I would say I'm going to do a couple of foundational questions here right now, but do put your hands up, folks, if you have some questions about what Matt is talking about on this topic or need clarification. Just put your hand up and you can go ahead and speak. So just a couple of other sort of baselining types of things. So you just said it's a very rigorous process to get to the endpoint of what you produced earlier this month, which adds to the credibility of the whole thing. Is it fair to say I did some chat GPTing on this, but is the ACI the main kind of creative originator of new codes that pertain to concrete? Is that kind of
for North America? Yes. There are parts of Central America and the Middle East and Asia that also use ACI codes. But Europe has their own core code organization that develops codes for there. All the codes are mostly similar because it's all based off of the same science. But yeah, ACI is the main group that's developing building codes for concrete. They're really the only group in the US that's doing it.
Okay. And in the US, whether it's at the state or municipal level, the main sort of core document is the International Building Code, many different documents, right? That's sort of the main thing that this is going to amend, right? This kind of references the International Code, right?
So it's unlikely that this will get into the main IBC, the International Building Code. It's more likely that this will start out in the International Green Building Code, which is also developed by the same people that develop IBC, the International Code Council. As you are all aware, there's a lot of politics around sustainability items. And so for that reason, ICC has kind of kept a lot of the sustainability stuff in the IGCC. And so states that want to move forward with sustainability can adopt that on top of ICC. And work those together. That's just the nature of the system at the moment. So, the gold standard would be to get into the International Building Code, but it's just not likely right now that we'll be able to do that.
Okay. And just one other question too, just in terms of the building code has all sorts of different things around building construction. I can't imagine how long it is if you were to put it together on paper. It's got to be enormous. What kinds of things are in there already in terms of codes that pertain to concrete? I don't mean number by number, but generally speaking, what is sort of regulated by code that covers concrete in
Yeah,
building?
so the main things that are regulated are the structural design aspect. So, how thick do your beams and columns need to be? How much steel reinforcement do you need to have in them? What strength of concrete does it need to be? That's probably the main thing that is handled there for in terms of concrete. You also see it coming up in some of the energy codes if you want to take into account thermal mass. Um, but that tends to be more on the optional side. We don't really have many codes on the material side, which we can get into why a little bit later, but mostly folks have the code work is focused on the structural end of the system.
Okay. I do have to say one thing. I think Garrett Casey, is that Garrett Casey, Massachusetts Garrett Casey, who just joined? Hate to call you out, man, but I just want to say if it is that if he could confirm that he's the legislative director for a really awesome senator in Massachusetts who's been all over concrete stuff. But you could put it in the comments if it is you, but great to have you. Um, and just last thing on just general sort of features here, what other types of sustainability related codes around concrete have come out of ACI, either in the green building code or general? Is this the first one?
This is the first one. There are some standards, there are some policies that have been put in place, but as far as ACI knows, this is the first code language for carbon reduction in concrete in the world.
Okay. And what caused, again, I always try to tell people don't beat up the concrete people. I love concrete people. And I feel like a lot of times it's more of just like, hey, we'll build what you want. You know what I mean? But I was a little sort of surprised that this is coming out of the actual an industry body for concrete. And I wonder if you could just characterize a little bit what led to this moment where you got the call. Maybe it was your own advocacy, but how is it that ACI finally, entered into sort of a sustainable area of code?
Yeah, ACI has been talking about sustainability for a while. It's been a hot topic for a while. We've had a number of committees dealing with it, but it wasn't until about a little over 2 years ago that we started to talk about moving forward with a code. And the main reason for that is actually all of you. Um, there has been so much policy being pushed around the country that is essentially writing code language into city and state laws. But it's all very scattered, right? Like it's not the same, it's a little inconsistent. People are taking numbers from one area and trying to use them in another area where they don't really work. So as an industry, we realize, okay, well, we need to be the voice on this because we're the experts about this, right? So everybody in the room on this code was, we're all believers in climate change. We're all proponents of sustainability. It was about how do we get this right and move towards something that is feasible. Because some of the things that we've also seen proposed are just straight up not feasible from a technical standpoint. And we know that when things are not feasible, they just get ignored, right? And
Yeah.
so we want something that's actually going to have an impact. And so that was sort of the impetus for us. It was a little reactionary on our part, but again, like I said, this has been moving faster than anything we've ever seen. Normally this many people are not interested in concrete.
Yeah, that warms my heart to hear that some of the stuff that we were doing in some has sort of forced the issue a little bit. That's sort of a meta phenomena of our advocacy, which is great. And Garrett, I didn't mean to call you out there, but I just do have to say, Garrett, you're on my mind right now. If you could make in a lab a legislative director for a senator to be awesome, they would look like Garrett. So sorry, Garrett, I'm going to embarrass you. You can turn your camera off, but He's just been extraordinary on some bills we've worked on in Massachusetts. So really glad that you were able to show up. All right, well, let's get into what the actual code is. Matt, let's kind of take this in pieces. It's got a number, but maybe you can just kind of describe what the code actually does, what it calls for.
So it's code 323, which is really just the number of it in ACI's hierarchy. It doesn't really mean much of anything. But what the code does is I'll start with what it doesn't do. It does not tell you how to make concrete. That is not the goal of the code. It does not have anything to do with materials or technologies in terms of making concrete. We very purposefully stayed away from that. One thing that we've seen from policy that's been implemented is that when policies that are put through that try to specify particular technologies, they get ignored. And that has to do with the fact that, not all technologies are available everywhere. Different things perform well in one part of the country that don't perform well in another part. Some things are just proprietary, and a code can't really push proprietary technology. So what the code actually does is it helps an engineer to determine a carbon budget for their building related to concrete. And we do this on a weighted volume basis. So basically, if you have an entire project, it's project-based. So it could be a building, it could be a bridge, it could be pavements and hardscape. It can kind of be whatever the scope is. But looking at all of that concrete, we try to set a limit, an average benchmark for what should be met. So basically, if you've got some concrete that needs to have a pretty high global warming potential, and that's what we use as the kind of carbon budget is global warming potential.
And what
If
is
you
that, Matt?
have,
You just define what that is?
oh, sorry. Yeah, global warming potential is essentially the amount of carbon emissions embodied in a particular material or system. It's referred to as CO2 equivalents. That's the unit is pounds or kilograms of CO2 equivalents, and it basically just takes all air emissions and normalizes them down to the same impact that a certain amount of CO2 would have. So methane has a much bigger impact on greenhouse action than carbon dioxide does. So we just normalize everything down to what carbon dioxide does, makes it a little bit easier to have one number. So we set a limit for global warming potential, and we've done this on a weighted basis because sometimes you don't have a choice. You have to use a mixture that's going to have a somewhat high GWP because you need to meet certain serviceability, strength, durability aspects. We know it's not required most of the time, but sometimes it is. And so when you do something where you just have a flat, no concrete mixture can have more than this GWP per cubic yard, it doesn't provide that flexibility. So when you go to a weighted system, you can offset some of that higher CO2 emitting concrete with some lower CO2 emitting concrete in another place. And this gives the designer a lot of flexibility to make sure that they're meeting all of their safety requirements. It also allows the designer to play with total volume of concrete that they may cast or not cast, right? So if you look at something like the Marin County Code, that sets a limit for if you use a mixture of 4,000, that's going to be 4,000 PSI. Any mixture you use that's 4,000 PSI can't have more than this particular GWP. And you can't play that off of, say you've got some 6,000 PSI that you can get much lower GWPs on because you can let it cure for a lot longer. You can't play those off of each other. Everything just kind of has a static limit. So that's why we moved to this weighted carbon budget, gives you that flexibility. And that is really the main thrust of the code is you set that carbon budget limit. We also provide benchmarks, so carbon benchmarks for different classes of concrete that help you determine that. So we're using the benchmarks that were created by the National Ready Mix Concrete Association. They did an analysis of member mixes that were submitted to them and provided some regional averages for different regions of the United States. And we say if you're going to use those, that we suggest your overall reduction should be, at this point, a 15% reduction. However, we recognize, some of you may know, those NRMCA benchmarks that they created are not actually very good. They are from a fairly low amount of data. They are mostly from metro regions. And so you've got the Northeast region spans from New Jersey up to the tip of Maine. But most of the mixes that were used to develop that average came out of New York City. And so what is a average good mix for New York City is not going to be the same up in Buffalo or up in Orono, Maine, right? They have access to different materials. Technology has moved faster or slower in those areas. And so really what we recommend is that if you adopt the code, you should develop your own benchmarks. That is basically impossible in most places at the moment because nobody has the data. We are an industry that has not collected data. Concrete manufacturers see their concrete mixture designs as proprietary information. Whether you agree with that or not, some courts have somewhat held that up. And so getting a lot of data that is, really clear is just really difficult at the moment. So it takes quite a lot of work to set benchmarks. But hopefully, as we move forward, I'm kind of ringing the data bell a lot. This sort of gets resolved moving forward.
This will create data as well. It seems like that's implied, right? Because you need, I don't know if it's mentioned in the code or not, but obviously you have an environmental product declaration has to be what verifies it. So you could see there are some places in states that already have things like buy clean policies in place where they already have some numbers that they've generated more locally. But it sounds like if you put this in place over the course of time, you'd start to be able to get local data that might allow you to revise the general NRMCA data based on what you're actually seeing as averages coming through as a result of this code. Is that fair to say?
Yes and no. So EPDs are going to be the main way that you can sort of prove that you're meeting the code limits. An EPD is great, but it actually doesn't provide all that much information. And it also doesn't provide any information on how much volume of that particular concrete mixture is used. So right now, unless somebody voluntarily gives us, we've cast this concrete mixture in this EPD and we've cast this much volume of it, basically we have to weight all the EPDs the same. And without knowing the volumes, it's not a very good average, right? Because you could have one EPD that has a very, very high GWP, but it's only been used very sparingly, where you have another one that has a pretty low GWP that's been used a lot. If you weight them the same, your average is not going to be correct. So those are some of the data sort of barriers that we have. It's pretty complex issue to resolve at the moment.
Okay. Sue just asked the question, SF, I think she means square foot. I'm guessing. Let me see.
We would want volume, so cubic feet.
Oh, safety factor.
Oh,
Okay.
safety factor.
Thanks, Rob. Okay.
There's no real safety factor here because this isn't a life safety code. The code says that you still need to meet all life safety requirements of any other code that is relevant to your particular system. So because there's nothing that can really go wrong in that sense, there's no need for a safety factor.
Okay. I'd like to pause and take some questions at this point in a second, but let me just summarize what I think I've heard so far from you, Matt. So what this code is, it's not based on prescriptive mixes. It's performance based, which is good in its own right. We want that anyway, in addition to all the reasons that you said, meaning that it's more around if concretes have this PSI or this kind of performance characteristic, you apply the GWP reductions to that, not to a particular kind of mix, right? That's sort of
Correct.
block
Correct.
one. Okay.
It sets a performance requirement.
Okay, which is good. And then the other thing is that what the code really does is it says, assuming the National Ready Mixed Concrete Association regional averages, that by implementing this code, buildings that are built within this, whatever the jurisdiction having authority is, have to be 15% below that benchmark. But it's also flexible enough that if somebody wants to introduce their own benchmark, a new one or one that they've already put in place through some other policy, they can have that be the threshold that the 15% goes below. Is that basically what we're talking about?
Yes, what we do say is if you set your own benchmark, you should also set your own threshold. Because depending on where you are and the quality of your data, that threshold, that the reduction may be more or less achievable. So that's a little bit up to the jurisdiction. But if you do use the NRMCA, we as a group came to the consensus that a 15% reduction was something that was achievable in probably 90% of the United States right now. And so that was why we went with that number.
Okay. Does anybody have any questions? Rob, thanks we have some legit blockheads on this call, Rob being one of them. He knows a lot. I see Doug is on here, Sue, some people that are pretty immersed in the field here. I do have one question for Harold. Harold, I can read it if you want me to, unless you want to speak through it. But if anybody else has any other questions, just go ahead and raise their hand or put it in the chat. What Harold asked was, if an EPD is for a particular mix of materials, how would validity of the EPD be dependent on volume? How much of it is used in a project, question mark, or is that what you meant to say?
Right. So the EPD isn't invalid just without the volume. It's just that to make a good average assessment of GWP for a particular area, we need both the EPD and the amount of volume of that concrete mixture that was cast. So otherwise, you can't sort of create an average value of all the concrete made in a particular area. Instead, all of the EPDs are weighted exactly the same, even though EPD-A mix may have been used this much and EPD-B mix may have been used this much.
So you're talking about a different use of the EPD than I was thinking about. I'm thinking about it as, let's say I have a particular project to do, and I'm trying to figure out how to keep the GWP low. I could go say, well, here's a material that's got a certain EPD and a GWP associated with it, and that's going to be independent of how much of it I need. Am I correct?
Sorry, yes, sorry. I was talking about the benchmarks and thresholds.
Okay.
Yes, your EPD is independent of how much you need, but the EPD is a global warming potential per cubic volume, right? So cubic yards usually.
Yeah.
So what our code allows you to do is you take into account the amount of volume that you're using on your particular project. And then that lets you sort of normalize. So if if I were working with just a baseline block of your concrete mixes must be below this GWP, that means I could never ever use a mix that goes above it, even if I might actually need to for serviceability, structural reasons. What our code allows you to do is if you need to go above on one mix, but you're only going to use a little bit of volume of it, you would offset that with another mix that you use more volume of. So it kind of lets the designer have more flexibility in the actual design and using the mixes that they actually need to use to meet all the requirements.
That's really smart. So it's like a whole building approach, but just for the concrete part. Like there's other
Yes.
persons that are looking at all of the embodied carbon of a whole building across all of its materials, but this just takes concrete, which is significant because a lot of different mixes used in building, and it usually amounts to 60 to 80% of the embodied carbon of a building anyway, is just concrete, I think. So, Rob.
Yes, thanks. Great presentation. Do you include gate to grave or cradle to grave in your assessment, or where does your assessment begin and end? Does it include transportation, for example? There's a company in BC that makes a hybrid electric cement mixer.
Which company is that, Rob?
That's Edison. They
Okay.
will custom make a vehicle to your specifications for service, as opposed to the long range semi trucks for the highway. But they only make 5 a year.
Yeah. You're breaking my heart. It's a concrete mixer.
Yeah. But it's
Uh,
hybrid electric, so it saves about 40% on emissions.
yeah, so our code is cradle to gate at the moment. It goes up until concrete leaves the ready mix facility. We would like it to go cradle to grave. Unfortunately, we don't have the standardized tools yet to actually get those values in a way that's comparable. People can do it. It's people can do a full life cycle analysis, but there isn't a standardized third-party verified item like EPDs for that whole system. It's probably coming. We are looking into it for the next stage of the code as well, see how we can take that into account. But we're not there yet. I also will say that our code was written in, uh, let's see, we had our first meeting in April of 2023. We had our first draft to the review board by the end of 2023. And then it took a whole year for it to get through all of the procedural stuff. So that's kind of a record for a building code in terms of getting that out. A normal cycle for a building code for just a revision is 5 years. And the way that we did that was by having a pretty narrow scope to start with, and sticking to sort of the tools that we knew were readily available. Hopefully in the future, we'll be able to expand upon that.
All right, we have a bunch of great questions coming in here, so I will ask them. First one I want to do, Pete, thanks so much from Long Beach. Just posted a upcoming webinar that's happening soon, and I guess two of the folks, Ignacio and Alex, are going to be involved in that. I'm going to give you a couple of minutes at the very end if you want to kind of put some color on that in terms of why we should attend, but definitely looks pertinent. So appreciate you guys for joining. All right, so let me ask one quick question before there's a lot of technical questions, but just a more of a general question. When you guys come up with codes like this, it's obviously a pretty Herculean effort that you wouldn't be doing it just for the hell of it, right?
Yeah.
Is it often what's the rate of implementation of new codes that come out of ACI in various different jurisdictions? Do a lot of them just sort of sit around as window dressing, or do they usually do a lot of them get put in practice?
They mostly get put in practice. I don't know of any that haven't been adopted somewhere, but they do take some time to get implemented. So I think the most recent one was a precast or pre-stressing code, which is a type of structural design tool. And I think that came out in the last code cycle, and it's been picked up by a number of places. But it does take time for those to kind of go through. Again, though, this code is sort of completely different. It's not structural, it's not life safety, so it's not as imperative that it kind of go through the whole ICC review process before it starts to get adopted.
This is a pretty big deal. It's occurring to me even more that, again, it's not just sort of an academic exercise. It's very much a practitioner. It's going to dictate
Oh,
change.
no, yeah, and I'll say there were 3 academics on the actual committee. Most of the people were active engineers.
I love it. All right, we have a couple of great questions here, which I'm going to link together. One from David, which is really good. And if you could roll into this and answer that 15%, that's a number that we came up with in LECLA's, and it might have even been semi-arbitrary when we came up with it. So I'm curious to see where that 15% came from. But what David asks, how do we translate this into what actual concrete producers will do? So he says, what are the typical things industry is doing, will do to meet this new standard? Changing cement that doesn't require as much heat, mixing in synthetic limestone, et cetera, et cetera.
So I'll start with the first part. The 15% is a consensus value. It was probably the most contentious item throughout the code writing process. It was a bit of a negotiation, to be honest. part of the problem is that when you're trying to define what low carbon concrete is, low is not a technical word, it's a philosophical idea, right? And so what my concept of low is different from what somebody else's concept of low is. And so, uh, there was one approach that some folks wanted to take, which was let's analyze everything that people are making and only have it reduced to what people are making. But in my opinion, we're not really, A, we can't get that data, and B, we're not then pushing people to go above and beyond. So this number really came out from a room of experts who work with these materials every day in all different parts of the country that know what is possible from their own mixtures that they're doing and seeing every day throughout their process. And so, I think there were folks that were afraid we're moving a little too fast for the industry. There were also folks that thought we were moving a little too slow for the industry. So this is really and through all the public comments, we got those on both sides. So if we're getting complaints from both sides, we're probably right around the right spot.
15 is a big number, I think, actually, based on you describing that to me, that they came up with that. And it seems to get us into the territory where it's not just the most obvious low-hanging fruit that will be used. This does seem to sort of force some new practices, probably. Is that your sense?
Yeah, yeah. So the number one way that people can work to get down their GWP is really just replacing some of the cement with other materials, so things we call supplementary cementitious materials. So these are things like slag, fly ash, glass pozzolans, calcined clays. Um, I saw my urban mining folks on here, so I got to shut them out. So that's probably the easiest way. That's the lowest hanging fruit in terms of mix design changes. The other tools that are at an engineer's disposal, the first one really is just uh, getting a spec review and getting performance or prescriptive requirements out of your specification. So there's still a lot of building specifications that say your concrete must have X% or X amount of cement, Portland cement in it. We haven't needed that in a spec for 30 years, right? It's just outdated but it makes a lot of engineers feel comfortable to know exactly that, oh, I know this mix has worked for me. That's kind of some of the momentum that we're pushing against, but we're looking to help people move towards more performance specifications. The other thing that is sort of easy sounding, it's not as easy as it sounds though, is just making sure that the concrete you get is the concrete that you're asking for, right? So a lot of times if I go out and I say I need 4,000 PSI strength mixture for this building, the testing will come back and at 7 days, my concrete will have 6,000 PSI, right? That is more strength than I needed, and I needed 4,000 at 28 days, and I got 6,000 at 7 days. That means there's too much cement in that system. Sometimes we have to do that for construction schedules or particularly difficult constructability issues, but a lot of the times we don't. So just sort of getting us to really focus on getting the concrete that we need and nothing more. That's actually a kind of a big ask from folks.
Yeah.
And then there's other ways to do this by sort of optimizing your aggregates, right? So cement paste fills in the space between your rocks and sand. If you can reduce that space as much as possible by getting a better gradation of your rocks and sand, then you will have less space that you need to fill with cement paste. So these are all tools that people can use. It's all a matter of the right tech transfer, right? There are a lot of concrete companies that do this already, that are ahead of the game. And those are mostly your big, transnational companies. But a lot of the smaller mom and pop concrete firms just don't have the funds or the manpower to spend learning about all of these different tools. And so that is sort of a barrier to access is even though they know they're out there. It does take some time to learn how to do it. You have to do test mixes in your facility. You have to make sure everything is working because each sort of set of mixes is slightly different. So it just takes some time.
Okay. Chris Sidwa, your name came up the other day on a call I was having with some advocates in Pennsylvania. Chris is with Urban Mining, who makes Positive, which is one of the coolest products. It's ground glass pozzolan, awesome New York company. Chris, please throw the link to your company in the chat if you can. I want to make sure people are familiar with it. Killian asked a great question related to that I don't think is one that you'll be able to answer, Matt. And this is a bigger problem that Killian's talking about, is that how do we make sure that the use of materials that are made from carbon from point sources or from the air actually factor into environmental product declarations and global warming potential? And there are some great people working on that. One person I'd love to introduce you to, Matt, but we should have on a call, is a woman named Anu Khan, who's working on the Carbon Removal Standards Initiative, and she's really looking very closely at this very question. And that's kind of upstream kind of what you've written here, Matt. You're about whatever's passes for GWP impact qualifies here, right? You're not
Right. If you've got it in an EPD that's third party verified, then it qualifies as something that can be used in the code. That question is really more about product category rules, which is the set of rules that a material goes through when an EPD is being developed. So what needs to be calculated, what needs to be reported, et cetera. And that is an area that I am doing some work in, but not on the carbon capture materials, more on the supplementary cement side. So I'm not 100% on, I don't know a lot about the different carbon uptake materials, to be honest. But yeah, there's, that's sort of upstream of where we are, like Chris said.
Yeah, that's another form of activism that I'm going to have Anu Khan in the seat for one of these soon. She can talk about that effort. Judy has a great example here. She's talking about there's a big construction project that Dartmouth is going to be doing, but it kind of addresses a larger question, like who adopts codes? I know sometimes the state adopts a code. Some have more home rule places where municipalities do. An institution like a college would be subject to the local code, but there's nothing that would stop them from saying, even if the code is not in place, they could say, hey, it's in the code. We're going to do this just for our own project, right?
Correct. Yeah. So actually, the very first part of our code is who can adopt the code. It's I think section 1.2 or something like that. Typically a state is where codes get adopted into law, meaning everybody in the state needs to follow that code. But moving down from there, anybody can actually require it. So a city can adopt it if they want to, because this would be this code goes above minimum standards, right? So you can't, if a state has a building code and a city wants to adopt something else, they can't adopt something that eases restrictions, right? That makes it, less strong or worse off, right? But they can adopt things that make it better, right? So they can adopt a more strict code, and this would be a more strict item. This would not kind of negate other parts of the code that the state adopted. And the same thing goes for owners. Owners can say, I want you to follow this code, and they're the owner. They get to decide sort of what is required for the building. So in this case, a university can adopt the code as sort of standard practice. And we're actually probably doing that at NJIT. I have been pushing it on my facilities folks pretty heavily.
That's great. We have so many good questions in there. I'm going to try to get to them, but I want to make sure we don't miss out on, this is a group of activists that you're talking to, Matt, surprise, surprise. So I want to just really talk about, let's start first with, I spoke to your colleague at ACI, Carrie, who's kind of looks like she kind of heads up the outreach and trying to popularize the code. What happens next in terms of under natural conditions, in terms of how this makes contact with people who make decisions at the state or municipal level? And then we want to talk about, this seems like a really clear-cut form of activism, where wherever we are, we could be like, hey, we want the new code going for it. But tell us a little bit about what happens next about making this real world.
Yeah, so we're working, ACI is working sort of our standard channels where we're talking to code officials and we're talking to legislators that are involved in code decisions about this code, introducing it to them, getting them sort of getting some buy-in, getting some industry buy-in as well. But what you as activists can do is you can reach out to your representatives, make sure that they're aware of this, figure out who in your state sort of manages the code system, and bring it up to them and try to push them to consider this and to adopt this. Right, there's some barriers to that in that you have to figure out exactly how the building code officials will sort of manage it, because that's a whole different process. Our code, it's outside of the scope of the code to tell a building code official exactly how to enact the code or manage it. And so that's some startup stuff that is required when you adopt a new code, and building code officials are already sort of overtaxed. So you tend to have a little bit of pushback there. So, working with the legislators to consider this and bring this in and maybe provide the code officials some more support in the meantime is probably the best way to go about it. And anytime you're out talking about low carbon concrete, say we've got this great tool, because this tool is, people don't know exactly how to set global warming potential, and this provides that tool.
Well, I'm going to put this directly in our Colorado bill. That'll be a line on there, shall enact code, blah, 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 right? But there's other questions here too about, Joel, there's a lot of people in California. California already has this Cal Green thing that I think you're probably familiar with, which already has, it might complicate things a little bit because I think that is a whole building thing that's not specific to concrete. I'm sure there was people within your group that worked on this that represented California. Was there much discussion? And we've talked about a form of activism about trying to get other cities in California to become a tier 2 city for Code Green. Do you know, Cal Green, do you know how this interacts with a place like what California already has on the books?
So this would sort of supplant what California has, because California basically has a carbon limit, not a carbon budget, in their code for concrete, and that's if you're just considering the concrete. They do also have provisions to do a whole building life cycle analysis, which is honestly going to be a better system than this. And so if somebody chooses to do a whole building life cycle analysis, it will probably provide a better offset than this code. This code is really just looking at upfront embodied. So that's sort of something that is going to work its way through the code development system as we figure out how it plays with all these different rules. But I don't really see this necessarily butting up against, in a negative way, any of the Cal Green or Buy Clean policies, because most of them are just saying all concrete mixtures need to be within this percentile of performance. And chances are that if you follow that, you'll also meet the requirements of this code. And hopefully, eventually, this code would supplant those requirements.
Yeah, and Joel and Pam, I would say that is an interesting kind of first step in a way, is even to email the personnel at Cal Green and say, ask that very question to them. You know what I mean? I'm curious how these things kind of do sort of.
And they're aware of the code, the folks at Cal Green. It just got published a week and a half ago, and so everybody was sort of waiting for the actual published document to come out before they made any actual decisions about anything. But most of these Buy Clean groups are aware of the code.
Okay. Harold asked another. So folks, let's just file that for a second. This is one of the more accessible kinds of activism opportunities I think we have. And so we can get into kind of brass tacks about that. It also has real LECLA implications, right, Matt? Because I mean, even though that's around procurement, if suddenly you're getting codes in there that have to do the work of, oh, there's this national ready mix threshold, or there's this or that, and with LECLA, what we do is you start to get an incentive if you get 10 or 15% below whatever that is.
Let me talk a bit about that, right? So I'm in New Jersey. I've been working with the New Jersey Department of Environmental Protection as they're trying to implement the LECLA law here. And one of the issues was, how do we define what low carbon concrete is? And that's what this code does. So it provides the tool for agencies to say, use this to calculate what low carbon concrete is.
That is super awesome. I'm sure Sue is clicking her heels around that. Harold brought up a good question about accountability, which is, what are the penalties? So he just mentions, for example, Marin County, that a builder cannot get a certificate of occupancy for a building unless it's verified. Is that typically how that would be operationalized at the municipal or state level? What's the
It's
penalty?
going to be really different in every state. That's a building code official decision, and a state decision that is way outside of the scope of the code. So I can't really speak to that, what they would do.
Okay. Bunch of other questions here. So we have Rob has another technical question here. Some cements tolerate up to 2% or more charcoal aggregate content without significant strength performance loss. How is this aggregate sequestration accounted for in the standard? That's a very technical question, but you might be up to it.
That's up to the EPD. If there's an EPD that accounts for it, then it's accounted for in the standard. The standard does not consider any individual technology or material.
Okay. All right, let's look. Scanning up here. Okay. So Carl, I don't know if you want to ask your first question. There's the federal stuff has been quite heroic lately, but a lot of that is probably about to get destroyed. If I had to guess, some of it won't. Carl, did you want to speak quickly to just that link that you put there? You had a question about whether or not what we're doing here is relevant to it.
Right. And first of all, thank you, both of you, Dr. Adams, for joining us and Chris for organizing it. Yeah, we've seen these periodic announcements like, oh, the DOE is, promulgating blah, 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 related to low embodied carbon concrete. And I'm trying to figure out the overlap or relevance or interaction between all these things. Is that announcement from DOE an example of something that sort of prodded ACI to move, or are they
So
unrelated?
the DOE announcement you sent is it's basically a research grant. And so that is a grant
Okay.
that is going to be given to one of the national labs, the National Energy Technology Lab, a group like that. And it's basically to help figure out the technical hurdles to different aspects of low carbon concrete. So whether that's at the cement plant with decarbonizing the cement plant, or what materials can be used and how they perform in concrete, that's what that's going to focus on. We also have money from the US DOT that's coming out, the Low Carbon Transportation Materials Program. That is really focused on providing DOTs the funding to train and educate engineers and offset upfront costs of moving towards newer materials, right? So basically, a state is going to get, I think at a minimum, $22 million. They can use that money to run a bunch of tests in the lab to look at a wide range of materials to see how they perform with their local materials in their local situations. And then they actually have to take a good chunk of that money and go out into the field to an existing project and do change orders and request low carbon systems that they've now approved. And so this money will pay for the cost difference between the system that they already have and what the change order would be. So that's the other thing. EPA's money that came out is to help mostly to develop EPDs, to help companies pay for the EPD to be developed. EPD's rule program or interim rules and labeling program, they're going to work very closely with this, right? So EPD is creating a tiered system for each individual concrete mixture. So it's saying like a concrete mixture for 5,000 PSI, here's a best in class for that. And so if you're trying to create a system and you want to go and find what the best in class are to use in your design, to use it and make sure that it's going to perform to our code, you can go to EPA and use their labeling program to do that. So all of these things really fit together. There are a couple of high-level groups that are talking to each other all the time on this to make sure that there is some overlap, but to really make sure that we're not duplicating efforts and we're all kind of keeping momentum moving forward.
Okay. We're running out of time here. I do have one other question from Doug. Sorry, we can get to the other ones. Matt Mallory had a great question, but hopefully we kind of covered that around. There's a separate battlefront about getting carbon utilization in concrete, making it quantitatively visible within EPDs. So we'll do a deep dive on that with Anu, hopefully in a month. In 2 weeks, I'd love to kind of metabolize what we've talked about and sort of look at what do we tactically want to do. I might reach out to Carrie as well, Matt, and see if she wants to join that call since she's kind of more on the advocacy or sort of public facing side. But the thing you just mentioned is a real point of sensitivity that I'm wondering if the federal monies that come in either directly from the Fed or through states, the concern for the little guy is a significant one. You know, there's a lot of the mom and pops that make up the industry, but then there's the larger, more consolidated ones. And there's a concern that if the larger ones can more easily comply with these, it puts the other providers at a disadvantage. And I'm wondering if some of that federal money and the kinds of resources and technical assistance, can that help create some training wheels for the little guy? Can some of that work be done through the state rather than on the shoulders of the little guy?
Yeah, yeah, absolutely. And that's part of the reason why that money is sort of coming out in the way that it is. And you know, most of the funding for EPDs is going to big sort of industry groups that individual companies can apply to help them offset the cost of their EPDs. The state can run testing in their lab as opposed to having the concrete plant have to run it in their lab. So yeah, it's all going to help sort of normalize the playing field here.
Okay, great. And I'll give Pete, Alex, and Ignacio, if you guys want to give a quick plug for your event right now, I definitely will be signing up for it if I don't have a conflict. But before I do that, Doug asked a really interesting question that's maybe more broadly around how cost impact was sort of figured into it, but specifically asked, was the use of a carbon price to normalize GWP considered? For example, minimize sum of unit cost of concrete, plus he's got carbon price times GWP for concrete that meets performance requirements. That's an interesting idea, but I wonder if that resonates with you at all, Matt.
Yeah, I mean, we had talked about it, but it was thrown out pretty quickly, mostly because we want the code to be adopted, and carbon pricing is a pretty fraught political item as well. So, you know, we were really, this was not the pie in the sky, blue sky code that would be the best in the industry. This was the sort of push us forward, but making sure that it's something that will actually get adopted and used, right? So that was sort of our mindset, and all of us have been involved in this industry for a while, so we were pretty clear on sort of what some of our boundaries were.
Okay, great. Well, that takes us to the hour. I'm so excited by this. This is really phenomenal. Thanks, Chris, for joining. Ignacio or Ignacio or Pete, did you guys want to say anything about your event? They might have all had to jump, but that does look good. Grab the link in there. In 2 weeks, let's kind of get down to brass tacks about what it would look like to try to push this out wherever we are. And Matt will be in touch probably a lot again, which I'm happy.
Yeah, please
right,
do. And if any of you are working with legislators and they need some technical input, feel free to reach out to me. That's part of what.
Whoa,
so
that's awesome.
And Chris, I think we're going to skip to 3 weeks because 2 weeks gets us the day before Thanksgiving.
Yeah.
So it'll be December 4th.
Okay. All right. That sounds great. All right, everybody. Thanks. Hopefully that was illuminating. I'm very excited by it. I see
everybody.
Is there any appetite or availability, Matt, in the future for talking about the details of the code? I mean, we talked about at 30,000 feet today. You know, it'd be, I think, very helpful to actually walk through it almost paragraph by paragraph and say, this is how it works.
I can do that. We're developing a number of those sort of training exercises that will be available for free. They're going to be coming out mostly in the new year. I've been focused on getting the actual code out, so now it's additional items out. So we'll be having a lot of that come out soon.
Great. All right. Well, we look forward to supporting you and working together with you. Thanks, Blockheads. See you guys after Thanksgiving. Enjoy the holiday.
Thank you, everybody.